Paul Campanis here. It's March, 5th?
Yeah.
2018, and I'm at health class at TLC, and I got a bunch of students here. And if y'all don't want to be in the video, then don't talk, okay? Ask the questions after, that's fine. So today we're going to talk about something that's really amazing, and that's enzymes. Who knows? Does anyone know what an enzyme is?
I do.
Yep.
I do.
Go ahead.
I don't know like a technical definition. Sorry, I'm lame. Enzyme is something that breaks down when you eat food.
Yeah, it breaks your food down. It does like the heavy, like you eat this like steak, and you know, steak stays around a while. Or you eat like a McDonald's hamburger or something, you know, and that'll stay there for a while. If you put one on the shelf, it would last for years. But those enzymes are things that do the work. And so I'm going to read from a book here called Whole by T. Colin Campbell. Did it get in the frame okay?
Yeah.
Okay, and I'm going to be reading from page 100. And this is talking about an enzyme. Actually, I'm going to start in page 99 and 98. And this is a picture of the enzyme right here. You see the picture?
Yep.
Yeah, I'll show everyone. And what it is, it's a huge molecule. And it's protein. It's a protein molecule. Okay? But it's a little bit different than that because of what it does. And I'm going to read you what it does. And I'm going to do quite a bit of reading here. I used enzymes earlier to explain why a part cannot be fully understood outside the context of its system as a whole, an idea that should become even more clear as we look further at the role they play in the body. Enzymes are large protein molecules present in all our cells that are, through a series of reactions, turn one thing, say a sugar molecule, called a substrate, into another, say a glucose-related chemical the body uses to synthesize fat, called product or metabolite. Think of enzymes as a large, fully automated factory. Imagine inserting a small log, the substrate, into one end of the huge factory building, and at the exit end, collecting a nicely designed salad bowl, the product. You could turn the log into a salad bowl by hand, of course, but it would require much more time and labor. The factory dramatically increases the efficiency of the transformations. Enzymes do the same inside cells, converting substrates into products very quickly while using very little energy. The reactions enzymes cause, the word biologists use is that they catalyze reactions. Rarely, if ever, occur without the assistance of enzymes. If they do, the rate of reaction, the speed with which the reactions occur, is a minuscule fraction of what is possible when an enzyme is involved, and the amount of energy required is much higher. Comparatively speaking, enzymes are very large. An enzyme molecule might be 10,000 to 20,000 times the size of a substrate molecule. So basically, an enzyme is like this factory, an automated factory. And so you got, like, say, wood coming into one end, and you got salad bowls and wooden forks and spoons. You got chairs, all these things coming out, tables, podiums, all these things coming out of the factory. And it does this in your body. It's pretty amazing, isn't it? When you think about, and then it shape shifts like thousands of times a second and makes into other kinds of factories and doing other kinds of jobs in your body. So when you look at the process of life, you see it as amazingly complicated. And now I'm going to read another part about the enzymes here. And then we'll talk about the sprouts. And we'll eat some sprouts too if you want. Okay, for an enzyme to be functional, this is page 100, it must fold into precise three-dimensional shape. How such complex folding can take place remains a mystery. A small chain of 150 amino acids making up an enzyme has an extraordinary number of possible folding configurations. If it is tested, 1,012 different configurations every second. It would take 1,026 years to find the right one. Yet a denatured enzyme can refold within fractions of a second and then precisely react with a chemical reaction. It demonstrates a stunning complexity and harmony in the universe. So I'm a big fan of enzymes. I think enzymes are awesome. Without enzymes, none of us would be here. You'd eat something and it would just take forever to digest. And what happens is when you're young, your body produces enzymes and at a really effective rate. But when you get older, it doesn't happen. And so you see what happens to old people. They get really, a lot of them get really fat. Their ankles swell. They start having lots of problems. They look really awful. And it hurts to even look at them sometimes. Like when I go see my father at the assisted living, there are a lot of people there that their enzyme production is just really bad, and it's causing a lot of physical problems. And then when you go to church, like you'll see a lot of old people, and that's what's happening is their body's not producing enzymes at the rate that they need, so they can't digest their food, and they can't get the nourishment they need. So that's what brings me to sprouts, because sprouts are an amazing thing. These are a kind of sprout. Let me get a good shot of that. And these are fenugreek. And these are really instrumental in producing a hormone called testosterone. Have you guys heard of testosterone? A lot of men that get to my age can't produce testosterone, and it really hurts them. Testosterone is what you need when you go to the weight room. When you go to the weight room, testosterone is what gets you to just act like an animal and just crank the weights. It's what football players and hockey players and boxers and kickboxers and those guys in the cages that fight, they need testosterone. That's what makes things happen in your athleticism. When you run, testosterone is what makes you pass people like they're standing still. And so it's really, this is a building block for testosterone, and it's got all the enzymes to deliver it right into your body. Now, these are two other types of sprouts. See, sprouts are loaded with enzymes because you eat them raw, and then they have all sorts of other nutrients that the enzymes deliver straight into your system. So these are like granulated muscle fiber. When you eat these, it's just incredible. It's like the protein in here and the amino acids just go right into your system, and there's enzymes in there to facilitate that delivery into your metabolism. So like Alex here does 15 chin-ups. Well, if he switched to a diet of like eating mostly this instead of maybe pasta, he'd probably be able to go to 30 or 40 or 50 or 100. And you see these super high-performance athletes, like guys that run across the desert, and this is what they're doing. These are the kinds of foods they're eating. So now, you guys won't like the taste. It's very bland. So we've got some SOS here, some salt, oil, sugar. And so you guys can pass these around. This is it's a healthy sort of form of salt. It's got a little sugar in it. And that one's like soy sauce, just a healthier form of soy sauce. So,
I don't think I did it with that.
Yep. Well, what you do is you might have some. So I'll open the jars here, and we'll have a little feast. And I'll stop the video now, Alex, and we'll chow down.
All right.